Adoni here with our talk for October 2022, October 12th, 2022, Wednesday. Our talk today is about wave-particle duality. Okay? What that means is that the photon acts like a point particle as well as a wave, okay? And the electron acts as a point particle, but it can be better expressed as a wave function. And the same holds true for the proton, the neutron, and the neutrino. Okay, so of those 5 particles, and I use the term particle loosely, okay? The photon has no rest mass, okay? Whereas the other 4 particles are indestructible and have a rest mass, okay? Now, you will only hear it here. You will only hear an explanation for a logical, physical explanation, okay? Now, physicists have magical explanations of pulling matter out of vacuum with energy, okay? Magical, okay? Out of a vacuum, okay? And back when they decided this, a vacuum to them meant nothing, okay? Now they're backtracking some, and they're saying there is some structure to the vacuum, but the structure that they envision is one of strings coming into existence, a string and anti-string coming into existence from energy, and then immediately annihilating each other. Okay, so I on the other hand believe in real things. Okay, I believe in Newtonian physics. I believe that there's a flow. There's a flow of ether particles to the center of the earth. And it's that flow of invisible particles, tiny, tiny particles, could be of Planck length, or it could be just a quintillion times less massive than the electron. Okay, a quintillion. A quintillion is 1,000 trillion. No, 1,000 trillion is a quadrillion. So there's a difference between the counting in the U.S. and the counting in Europe. Okay, something we don't need to talk about today. But a quintillion is 1,000 quadrillions or 1,000,000 trillions. Okay, so you already have the electron that is about 1/1850th the size of the proton. Then you have the neutrino that's about 1/1,000th the size of the electron. Okay, so 1/1,000th. Okay, so that would be what I'm saying is we're talking that the God particle ones that I define, GP1s, okay, the tiniest particle of mass, gaseous particle of mass in the universe, okay? So I grow the universe from GP1s hooking up together into strings, and then the strings get woven into sacs, and then you end up with a neutrino sac, okay? So you have a neutrino sac, and then the neutrino has mass, and it also oscillates to different masses. Okay, so we get a lot of neutrinos from the sun, and they've discovered over the past 50, 30, 40, 50 years that the neutrinos have different flavors, means they're different kinds, and each kind can have a different mass. Okay, but it's a matter of the percentage. One flavor has more large mass neutrinos, one flavor has medium mass neutrinos, and one flavor has more electron neutrinos. But they all have all three masses. They're called eigenstates. So I see you guys are trying to run away. So back to the duality. But we'll get to the duality. But the first thing to understand is that the electron, if you view it as a sac, as a permeable sac, okay, then we have a way to store mass and energy inside the permeable sac. Okay, modern day physicists do not have an actual physical, they have a magical way of storing energy inside the indestructible proton sac. They have a magical way of storing energy inside the indestructible electron sac. But what I say is, since those sacs are indestructible, the four sacs, the nucleon sac, the proton sac, the electron sac, and the neutrino sac, those four sacs are indestructible. And not only are they indestructible, but they can permanently hold both mass and energy. Okay, so how is that mass and energy stored? Nobody asked that question because they don't have an answer. Okay, they say gluons, massless gluons, keep the quarks together, and that's how energy is stored inside nucleons. Okay, now I give it a physical being. I say an electron cannot be indestructible unless it's inside a permeable sac, and it cannot store both mass and energy unless GP1s are compressed inside. Okay, so it's like pumping up. They do pump up atoms or electrons. So they say, okay, so physicists are attached to pumping up the electron. Okay, but ionized particles give off energy too. So the electromagnetic waves are not just from electrons going to different energy levels. Okay, because if you have ionized particles, you have a plasma, and that plasma is going to radiate electromagnetic waves. Now, the electrons may be out there somewhere, okay? And that plasma can be at different temperatures, okay? So it's okay. You can use it as an actual physical sac because it behaves as a particle. Now, you can also view it as a sac because it's permeable and it pulsates GP1s in and out, and those GP1s harmonize into electromagnetic waves, okay? And they also harmonize into into gravitational waves. So this you're not told. An electromagnetic wave can best be viewed, okay? It can be viewed one way with electromagnetic waves perpendicular to each other, plus and minus, or it can be viewed as a highly compressed bead. So you have a highly compressed bead of electromagnetic waves, and you have a highly decompressed bead of electromagnetic waves. And the difference in pressure between those two beads is how strong the wave is. and depending on if they have equal amplitude, okay? But if if the vacuum part has a higher amplitude than the pressure part, then you have a gravitational wave, okay? So the net harmonized electromagnetic waves from Earth as Earth material heats up is gravity, because the amplitude of the vacuum part of all the electromagnetic waves that leave Earth is the amplitude of the vacuum part is higher than the pump or pressure part. So you have low GP1 ether pressure and you have high GP1 ether pressure. So that difference in pressure is what determines whether the net is a gravitational wave or the net is an electromagnetic wave that pumps out. Now, the easiest way to understand this is to look at what's going to happen to our sun in about 5 billion years. In about 5 billion years, our sun is not big enough to convert helium to higher elements, okay? Since it can't make lithium and it can't make the next element after lithium. Okay, so the sun cools, and when it starts cools, it blows off half its mass. Okay, so the beads, the electromagnetic beads, high GP1 ether pressure, low GP1 ether pressure that make up an electromagnetic wave. Okay, right now, they net implode GP1s into the matter on Earth, and that's how you generate gravity. Okay, in 5 billion years, when the sun's matter, or I meant the sun, when the sun's matter starts cooling instead of heating up, okay, it's also given that the sun has been heating up since it was a cloud at 10 degrees Kelvin, okay? And it's also given that in 5 billion years, okay, that our sun, in 5 billion years, our sun will start cooling. And when it starts cooling, it starts generating dark energy, okay, because they don't know what's pushing the gases away. They don't know what's pushing. Modern physicists do not know what's pushing what is going to push half the mass of our sun away in 10 billion years. The reason they do not know this is because there was a Michelson-Morley experiment in the 1890s. And that experiment supposedly proved that electromagnetic waves do travel in a medium. So that was a mistake of Michelson-Morley, and that mistake was incorporated into Einstein's relativity and the speed of light in a vacuum. And that mistake continues, okay? Because of the Michelson-Morley mistake, then all the modern day physicists after it, and including the 3 million physicists of today, none of them, okay? I'm not a physicist, but I'm Adoni, the physics truth seeker. I'm seeking the truth, okay? I'm seeking possible ways that both matter and energy can be stored inside a permeable sac, okay? So you have a physical structure for the proton. And there's no doubt that the proton goes through a cloud chamber and it has a charge and it's a particle by the way it streaks. There is no doubt that the electron, as it goes through a cloud chamber, is a particle and it streaks. And there is no doubt that the muon, once you pump up the muon with lots and lots of GP1s at extremely high, with extremely high laser pressure. Okay, so what a laser pressure is, it's a beam that has high amplitude compression, GP1 compression beads, and low amplitude compression beads. And the difference between those two beads, not the difference in pressure, it gives the laser beam its amplitude. And it's that amplitude that can pump up. It can pump up. Let's say you have some helium in a chamber, and you shoot it with the helium gas dense. You shoot it with a laser beam, and out will come muons and pions. Okay. Now the pion is going to decay to a muon. Okay, but the thing is, the muon temporarily for 2 millionths of a second has 207 times the mass of the electron. The electron has 5.511 keV of energy. Okay, and the muon has 207. It has 105 MeV of energy, but it's 207 times more massive than the electron. Okay. Now they determine mass by the amount of energy released, X-rays and stuff in 0.2 microseconds. Okay. A microsecond is a millionth of a second. So this would be 2/10 millionths of a second. Okay, that's how quickly, or 2 millionths, maybe 2 millionths of a second, two microseconds. Okay, so 2 millionths of a second, the muon is going to decay back to electron. So the electron sac is indestructible. You can pump it up, but then the holes in it get bigger, and the pressure is so high that once it gets out of the laser beam. So, and we're given that electrons and protons, they have magnetic poles. Okay, they have a spin. Proton has a spin. And the best way to view it is like the Earth. The proton has a magnetic north pole and a magnetic south pole. Now, you're only going to hear it here. Physicists do not know what the mirror image of the proton, the antiproton, is. They know it has a different charge, but they don't know. I mean, it's identical. They don't know what the difference is. So check this out, okay? It's original. You're only going to hit it here. Okay, so we're given that the proton is a little dynamo. It has a spin, has a magnetic north pole, has a magnetic south pole. Okay, if you look down on the magnetic north pole of a proton permeable sac, okay, it will be spinning clockwise, and the antiproton will be spinning counterclockwise. What that means is they're magnetic flux lines at the subatomic level. And by the way it lines up, the in and out pulsations hovering of the proton is what gives it its charge. So a proton and antiproton, if they're close enough together, because the spin relative to the north pole is different, okay? The proton goes clockwise, the antiproton goes counterclockwise. That gives them the separate charge. They attract each other. Now, though the sacs are indestructible, the sacs are indestructible. Okay, except except when a proton and antiproton meet. The reason they annihilate each other is because they cut holes. It's like two diamonds, okay? You know, a diamond can be shattered, but it can't be cut. Can't be destroyed. So just pumping up an electron or pumping up a proton to something, okay, does not destroy the sac. But the sac cannot hold the extra GP1s and the extra pressure. So it decays back to a proton, okay? Same thing with the muon, it decays back to an electron, okay? But if you have an electron and a positron, they're going to attract each other. Then they're going to hit. The two sacs are going to hit, and then they're going to annihilate each other, and then you get two X-rays in different directions from the holes in the sacs. Okay, we'll continue with Adoni the Truth Seeker. We're gonna get down to the nitty-gritty truths, to Newtonian physics, to how both mass and energy are stored inside the four indestructible sacs that can permanently hold both mass and energy. And then, I don't know if I mentioned, but those sacs hover, okay? And when I was discovering this and postulating this back in 2019, I looked up hovercraft, and there are a lot of interesting videos with the British military and their hovercrafts, as well as amateur hovercrafts and recreational hovercrafts. Okay, talk more soon. Thank you for watching. Bye.